Hello everyone. In this video let's talk about one property of graphs, that is coloring. There are three types. First one is vertex coloring, then edge coloring, then face coloring. Now let us see about vertex coloring. It is the assignment of a color to each vertex of the graph so that no two adjacent vertices are assigned the same color. For example, consider this graph. Now give red color to vertex A, since the vertices B and D are adjacent to A, and so don't give red color to B and D. Also B and D are not adjacent vertices, so give blue color to B and D. Now for C, don't give blue color but give red color because A and C are not adjacent. So coloring is nothing but for every vertex you should give a color so that no two adjacent vertices should get same color. Let us see what is edge coloring. An edge coloring of a non-empty graph G is an assignment of colors to the edges of G, one color to each edge such that adjacent edges are assigned different colors. I will explain this with example. Consider the graph. Since E1, E2 and E5 are adjacent edges, so you have to give three different colors to E1, E2 and E5. If you give red color to E1, blue color to E2 and green color to E5, then you can give green color to E3 and red color to E4. Then face coloring. A face coloring of a plain graph is just a vertex coloring of its dual. For example, consider the following graph. The problem is to color this graph such that no two adjacent regions share the same color. This can be done like this. Represent each region by a vertex. Then use edges to connect the vertices of regions that share borders. Finally, use the procedure for coloring a graph. This is the resulting graph. Now let us see some terms related to graph coloring. First one is N coloring. N coloring of a graph is a coloring using N colors. Then N colorable. N colorable graph is nothing but a graph which can be colored with N colors. For example, consider this graph. This graph can be colored with two colors. So that why the graph is called two colorable. We can color every vertex with different colors. Still it is possible. In the fundamental definition of graph coloring, only one thing is mentioned, which is no two adjacent vertices have the same color. Next, chromatic number. Minimum number of colors required to color the graph is called chromatic number, which is denoted by I of G. That is, the chromatic number is the minimum value among all n's such that the graph is n colorable. Consider this example. This graph is 3 colorable and also 2 colorable. That's why chromatic number of this graph is 2. Let us see about some contributions made by great mathematicians. In 1852, Francis Goodhart, a British mathematician, postulated four-color theorem. Then in 1879, Alfred Campe claimed proof for four-color theorem. In 1890, Haywood proposed five-color theorem. In 1976, Kenneth Appel and Wolfgang Haken proved four-color theorem. There are many applications of graph coloring like making schedule or timetable, mobile frequency assignment, Sudoku. Graph coloring has its application in register allocation and map coloring. Thanks for watching.